There's a spacecraft launched from Earth going in this direction here, 50 degrees, and we're given that the right spacecraft with respect to the Earth is going to be a velocity of 0.58 c. So that's this one. And then another spacecraft is moving over here to the left. So the velocity of the left spacecraft with respect to the Earth is going to be negative 0.73 c. So we're trying to figure out what is the velocity of the right spacecraft with respect to the left spacecraft here. And in order to do that, let's just set up the relative velocity formula here. So we know it should be like we'll figure out the x direction first. That's just going to be equal to v of r with respect to essentially another observer. So you'd need another one in here, because technically this should be like a 3 and a 1. So then this thing would be the 3 and then the 2 right here. So then we can add a v of the e with respect to the L, and this would be the 2 to the 1 over here. So that way you kind of get the 2's canceling out here, the e's canceling out, and that way you can be left with the r and the L on the outside over there. When we do that, then we have to divide that by 1 plus these two velocities multiplied over here. So VRE times VEL, and divide that by the c squared. So let's see if we can just plug in these values now. The v of the right with respect to the Earth, going along only in the x directions here, by the way, all these for x's, then we're going to be looking at this, which is just simply going to be 0.58 cosine of the 50 times some c, but we're just going to kind of put the c like way out here, because it's kind of like at the very end of our answer we're going to have some c multiplied in here. But over here we have the Earth with respect to the L, so that's going to be these guys. Notice how it's supposed to be negative, but that was if it was L with respect to E. Here it's E with respect to L, so we have to flip the sign, so it just becomes positive again. So 0.73, and there's the C, but we pulled it outside already. So it's like a big parentheses here. On the bottom side, consider that these two V's already have C's in it, so we're going to get a C squared, which will cancel out with this bottom C squared. So we can just think of this as 1 plus the decimal values here. So 0.58 cosine of 50 times the 0.73, and then that's it right there. Let's go and plug this in the calculator. We're going to see it's 0.58 cosine of 50 plus the 0.73. Then we have to divide that by 1 plus the 0.58 cosine of 50 times the 0.73. So we get that the v of the r with respect to L in the x direction is simply 0.8669. And then we have the c at the end, which is why we pulled it out here. Boom. Now let's try to set up the same equation for VRL, but this time in the y. So to do that, we start off with the v, same thing over here, VRE, and this is going to be now in the y direction instead of the x. Then we have to multiply this by the square root of 1 minus this particular value, VEL, and this is still in the x direction here. Then we square that divided by a c squared. And then over here on the bottom side, we have 1 plus the v of the REX, VELX divided by c squared. It's actually the same thing as over here. Let's try to plug in these values. So we're going to notice that the v with the r with respect to e is going to be, in the y direction at least, is this, which is going to be the sine version. So we'll have 0.58 sine of 50 times the square root of 1 minus e with respect to L is this. There's going to be a c squared in there, so we're going to get rid of those. And we're just going to have 0.73 squared in there. And then we're going to go ahead and divide this by 1 plus all these things that we did already. So 0.58 cosine 50, and then times the 0.73 at the end there. And that'll give us, plug this into the calculator, we got 0.58 sine of 50 times the square root of 1 minus 0.73 squared divided by 1 plus 0.58 cosine of 50 times 0.73. So we get that this is the v of the r with respect to L, and the y is 0.2387c. At this point, we just have to take the Pythagorean theorem to figure out what the magnitude is here. So we're just going to go 0.2387 squared plus 0.8669 squared, and square root that. So we get that the VRL magnitude is going to be 0.8992c. Now, if we want to find the angle for this, we're just going to take the arctangent of these values over here. So the arctangent of the y over the x, 0.2387 divided by 0.8669, and we should get the angle is 15.4 degrees.